Very warm greetings and wishes, dear friends and students. Today we are going to see about the how to find the deflection slope using the method of Macaulay's method. You know that using double integration, how we are going to find the deflection and slope at various point or maximum deflection and slope can be determined, that we have seen the previous three videos. Now we are going to find how to find the slope and deflection for a Macaulay's method. So this Macaulay method is the modification of double integration method. So in this method can be used where the loading is discontinuous. For example, if you take a simply supported beam, there are 2-point load, 20 kilonewton and 30 kilonewton acting at 2 meter and 3 meter of a total span of 5 meter from the left end. So these 2-point loads are constant load for a simply supported beam. You cannot able to find the slope and deflection using double integration method. That is the very first method. But in this method, Macaulay's method, you can able to find the slope and deflection under the load, either 10 kilonewton or 20 kilonewton load under the point I call it as C and D, where it takes the support at left support is capital A and right support is capital B. Or you can find the slope and deflection at any other point, either at 1 meter or 3 meter or 4 meter from the left hand support or from the right hand support. That is possible. So here also the fluctual rigidity is different or constant value, or the cross section is different or constant value, constant cross section. You can use this method. That is the greatest advantage of the Macaulay's method. So it is also called as the modification of double integration method or modified double integration method. So here I am taking 2-point load, which is of 20 kilonewton and 30 kilonewton, which is at a distance of 2 meter and 3 meter from the left hand support capital A. The total span of the beam is 5 meter. So you know that the total load is 20 plus 30, so 50 kilonewton. So if you are working out the reaction by taking moment equilibrium at support B, you can find the reaction at A, that is VA. So VA into 5 minus 20 into 3 minus 30 into 2 is equal to 0. So you can able to find the reaction. So if you are working out the reaction, so VA into 5 is equal to 20 into 3, that is 60, plus you can get another, that is 30 into 2, again 60, right? So 60 plus 60, 120. So therefore reaction VA is equal to 120 divided by 5. So here we are getting a reaction at A is equal to 120 divided by 5. So we are getting 120 divided by 5. It is nothing but, so it is 20 plus 4, that is 24 kilonewton. So the left support is having a load of 24 kilonewton. And the right hand support B, that is VB, can be determined by using the vertical equilibrium. So total load is 50. So 50 kilonewton. So that will be shared by V and VB. So therefore VB is equal to 50 minus 24. So 50 minus 24 is, we are getting 26 kilonewton. So 26 kilonewton is the vertical reaction at B, VB. So VA is 24 kilonewton upward, VB is 26 kilonewton upward. So if we add, we are getting 50 kilonewton. So So total upper load is equal to, that is reaction is equal to 50 kilonewton. Total downward external load is 50 kilonewton. So it is having a sigma v equal to 0. So that is the right answer. Then here EI d square I by dx square is equal to, I am taking the first portion, that is AC portion, take a section XX at a distance small x. So you are getting the moment is right 24 into x. So that will be proven by the dotted line. After that I will go the right CD portion. What will happen between 20 and 30 kilonewton? I will take a section XX from the left support between CD. Now put the dotted line, the remaining load is, what will happen? So minus 20 into x minus 2. Then go to the third region. You put the dotted line. Third region is minus because anti-clockwise for the 30 kilonewton. So dotted line minus. Already these two portion has been completed. The third portion is minus 30 into x minus 3. So EI d square by dx square is equal to minus 24 into x dotted line minus 20 into x minus 2, then dotted line minus 30 into x minus 3. So I call this as the moment equation 1. After that I am integrating once. What will happen? So in the first region, if you are taking, what will happen? EI dy by dx is equal to minus 24 into s square by 2 plus constant of integration. So dotted line minus 20 into x minus 2 whole square by 2. Then dotted line minus 30 into x minus 3 whole square by 2. So the constant of integration is C1. By using the boundary condition, you can find the value of C1. Then once again integrate the slope equation, you will get the general deflection equation. So therefore EI into y, where y is the deflection at the required point. So that is equal to minus 24 into x minus 2 whole cube by 3. Already it is 2 is there. So 3 into 2 6 plus C1x plus C2. I am putting C1 C2 in the first term itself. Then dotted line minus 30 into x minus 2 whole cube by 3 into 2, what is happen 6. Then dotted line minus 30 into x minus 3 whole cube by 6. So this is the general deflection equation. So we have determined the general slope and deflection equation. Then you can convert the constant of integration C1 C2 using the boundary condition. When x is equal to 0, that is a 0 meter, you know that deflection is 0. So substitute in the general deflection equation. So therefore EI into y, so that will be 0 because y is 0. So E is equal to 24 into x cube by 6 plus C1 into 0, that term is 0 plus C2. So because the support A is coming in the first region, you take the first region itself. So if you are working out, 0 is equal to right C2 plus 24 into s square, that will be 0. So therefore right C2 is equal to 0. Similarly you find right the constant of integration C1 by applying when y is equal to 5 meter, that the foremost end of simply supported beam. So you simplify, you will get the second constant. After determining the constant of integration C1, C2, you substitute in the general slope equation and deflection equation, you get the final slope and deflection equation. Then after that, you substitute the corresponding value of x. When x is equal to 0 means at the support A. When x is equal to 2 meter means at the first point load of 20 kilonewton. When x is equal to 3 meter means at a under the load of 30 kilonewton, that is second point load. Or wherever you want, you can substitute when x is equal to 4 meter or x is equal to 2.5 meter or x is equal to 3.5 meter. So you can find the slope and deflection, the deflection and the slope equation finally you can arrive for the deflection in meter or millimeter and the slope in radian. If you want to convert, you have to multiply by 180 divided by pi. So this is how we have to find the slope and deflection in the case of the Macaulay's method or modified double integration method. So this the major advantage is what for a discontinuous load or the cross section is different or the fluctuativity is different. You can use this method, but you cannot work out the slope and deflection in the case of the previous method, that is double integration method. So that is the main merit or the advantage of this Macaulay's method of determining the slope and deflection equation. Thank you very much for patient listening. God bless. வாழ்க வையகம், வாழ்க வளமுடன்.